transfer by conduction. Okay, it's chapter 4. Well, basically, minta maaf lah kalau siapa yang belum breakfast lagi tu, bolehlah grab apa-apa kan. Okay, memang purposely untuk buat ni ni panas lah. Letak burger kat dalam slide ni kan. Okay, so basically just to show the concept of heat transfer, specifically for conduction. Okay, so you know that dekat atas ni tak ada apa lah, basically dia gas punya stove je. Okay, and dekat sini is basically to show you that macam mana apa ni cheese ni boleh melted on top of the burger patty ni kan. Okay, so it is basically the concept of conduction. Okay, so itu nawaitu asal dia lah. It's not to buat you terliur ke apa benda ke kan. Okay, let's just keep that. Okay, this will be the title. Okay, so what are the words for heat conduction? Okay, it can be conduction, thermal conductivity, thermal conduction, heat conductivity, and so on and so forth. Okay, this is the communication in between the students and the professor lah, tapi dalam bentuk burung macam apa ni lah, apa kartun lah. Okay, tak ada apa pun. Right, okay, this is basically being defined on the previous slide. Okay. By the way, the slide is already in the folder. Okay, except for conduction. Conduction ni saya belum masukkan lagi. After class ni saya akan try to include this slide lah in the Moodle, okay, so that you can get it. Okay, the first slide semalam tu saya dah upload lah. Okay. So conduction, the definition is the transfer of energy from the more energetic particles of a substance to the adjacent less energetic ones as a result of interaction between the particles. Okay, so this one is the definition by Chengel and Gajar 2015, whereby this will be the books that being used as the reference book lah for this heat transfer. Okay, particularly heat transfer lah. Okay, kalau I think maybe you have already gone through this ataupun you familiar with this book during your diploma time lah. Kalau siapa yang ambil diploma tu mungkin ada buku dia, dekat depan buku, kulit buku dia tu ada api, ada gambar api. Okay, so that is Cengel and Gajar lah. That one is the version yang lama lah, version baru dah 8 version, 9 version dah kot. Okay. This one is the version on 2015. I think not much difference lah, from one version to another. Okay, just mungkin dia update in terms of the reason, perkembangan ke apa-apa je lah. Okay. Okay, in gas and liquids, gases and liquids, it's due to the collision and diffusion of the molecules during their random motion, because gas and liquid, the molecule and also the atom is quite far from each other. Okay, not as tight as solids. Okay, so when we have solid, the combination of vibration of the molecule in lattice and the energy transport by free electrons. It's either by the vibration or the free electron movement. Okay, so for example, cold can drink in a warm room. Okay? Cold can drink in a warm room. Okay? So ada berpeluh dan sebagainya is basically as the effect of the heat transfer activity. Okay. Okay, we go straight to the rate of equation for conduction. So rate of heat conduction will be depends on several factors. Okay, it includes thickness. Okay, thickness, which is delta x. Okay, Sometimes you call it sometimes you call it data X. Okay. Sometimes you call it L. Okay. So data X. Okay. Data X and L. Okay. And then you have also material. Okay. So this one is related to K. Okay. Normally we will only consider K because we don't have any for conduction. There will be no motion. Basically, it's a the bulk condition of a material. Okay, or the stationary condition. Okay. And of course, this one is the major one, which is delta T. Okay, and this one will be depends on the geometry. So it will depends. It will reflect to A lah. Okay. So the geometry ni we have a bit ni je lah yang conventional geometry lah. Kita tak ada yang pelik-pelik macam fin ke apa ke, tak ada. Okay, kita ada plane wall, we have cylindrical wall, hollow, okay, hollow cylinder, okay, and we also have sphere. Okay, tiga tu je lah. Another one is that one is in convection lah. Kita panggil annulus. Okay, annulus ni is basically macam dalam drilling you tu lah. Okay, you have annulus kan. So basically dia adalah cylinder, tetapi dekat tengah-tengah dia ada lubang. Okay, in between internal diameter dengan external diameter tu ada lubang kat tengah dia. Okay, kat dinding dia tu berlubang kan. Okay, that is what you call annulus. Okay, so that one in conduction we don't have that lah. We only have that uh, in convection. So for the timing tak ada dalam dia tu. So this would be the four factors whereby will influence the rate of heat conduction. Okay, right? Okay, consider heat conduction through a large plane wall. So basically, this is the repetition of the previous session, but we will go detail on this one. Okay, if you ever go to this this slide. Okay, we have delta X as the wall thickness. Okay, delta X for wall thickness, and then we also have delta T. We have T1 on, we call it inside the wall lah. Okay, inside the room ke. Okay, and T2 is outside the room. Okay, okay, meaning that T1 is at X is equals to 0. T2 is at X, delta X equal to delta X lah, ataupun L. Okay, so from this alone you can create a profile. Okay, whereby the difference in T, because it is a linear relationship. Okay, so you know that how much the temperature will travel along the wall. Okay, so from one point to another to is in between 0 to delta X ni is the temperature profile for this particular system. Okay, so you know that at the point, one point dekat dalam ni, so the temperature will become that particular temperature. Okay, so you can formulate another formula lah rather than you have this one. It's only to relate those two variables. Okay. And you also have you also have A tadi tu. Okay, for area. Okay, and A ni is basically dia tak nampak normally bila buat macam ni, because basically dia uh, surface lah. Okay, and dia kat tepi ni so basically yang ni adalah dia punya ni height dia, so yang ni adalah dia punya width dia. So normally height times width is A lah. Okay. So kalau plane macam ni kita tak nampak. Okay. And you have Q as a rate of heat transfer, meaning that kalau ada dot ni is rate lah, meaning that per unit time. Okay. So basically this would be the experiment, okay, that's being performed. Okay. So based on that experiment, okay, when Q is double, okay, when Q is double, when delta T or A is double, okay, when delta T and A is double, T1 minus T2 and also A is double, Q will also increase, okay, proportionally compared to delta T and A tadi lah. Okay. And once you half it, okay, ataupun once you double the value of delta X ni, you will find that delta Q is half. Okay. So in essence, we will know that that will be the relationship of the uh, the variables of the rate of heat conduction. Okay. So rate of heat conduction will proportional to the area and temperature difference, and it is inversely proportional to the thickness, okay, of the wall. Okay, but there should be one coefficient that might relate in between those parameters ataupun those variables. It is being called thermal conductivity. So in the proper equation, we will have Q, Ka, delta T, delta X. Okay, Q is equals to, conduction is equals to Ka, delta T over delta X. The negative value is to signify that the gradient is negative. Okay, and it is being called Fourier's law of heat conduction. And if we move A to the other side, we will have Q conduction over A. It's being called heat flux. Okay, the only difference is that this heat flux is per unit meter square. Okay. So that would be the fundamental of heat conduction. Okay. Okay, this one is the example based on equation ni tadi. Okay. Right. Bagus kalau bawa equation ni ke sana. Bawa ke sana bagus. So that you can payah nak ni. Okay, cuba ambil masa sikit untuk buat, dapat tak jawapan tu? So you have this system, okay, the thickness of the wall is 25.44 ni, okay, 25.4 millimeter. Okay, so it's basically you have to convert it to meter lah. Okay, 0.25 0.025 lah. Okay, fiber insulating, and you have the temperature inside and outside is 352.7 Kelvin and also 297.1 Kelvin on the outside. Okay, so when you try to find the difference, and you will get delta T lah. Okay, T1 minus T2. Okay, this one is 352. This one is 297.1. And you have the conductivity value of 0.048. Okay, and they only basically they only want you to determine heat loss per meter square. So you are looking at the heat flux dia sebenarnya. Okay, it's not Q conduction pun. It's Q conduction over A, or you can always assume A as 1 meter square. So you will get um, the answer of 105.1 watt per meter square lah. This is very easy punya calculation lah. Suppose you boleh dapat. Okay, very straightforward.